Preparing for a JFrog Solutions Engineer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you explain JFrog Artifactory to a customer who currently stores artifacts in Git? Git is designed to manage source history, while Artifactory manages build outputs and dependencies throughout their lifecycle. I would show how a Maven, npm, Docker, or Helm artifact is published once, versioned immutably, and consumed consistently by pipelines and teams. Artifactory also provides permissions, metadata, remote caching, and cleanup policies. That reduces duplicated downloads and prevents builds from depending on developer machines. I would tailor the demonstration to the customer's existing package managers and release process. While answering, distinguish source control from artifact management, explain binary repositories, immutability, metadata, dependency resolution, lifecycle management, and how Artifactory supports multiple package formats and scalable C/CD workflows. Question 2. How would you design an enterprise repository structure in JFrog Artifactory? I start by mapping teams, package types, environments, and promotion boundaries. Local repositories hold internally produced artifacts, remote repositories cache approved external dependencies, and virtual repositories provide a stable consumer endpoint across both. I use clear names, separate production and development policies where necessary, and project-based permissions rather than broad administrator access. I avoid creating a repository for every team unless isolation demands it. The design should simplify builds, support traceability, and remain manageable as adoption grows. Make sure to cover local, remote, and virtual repositories, naming conventions, project isolation, promotion paths, permissions, repository keys, package type considerations, and avoiding unnecessary repository proliferation. Question 3. What is the difference between local, remote, and virtual repositories? A local repository stores artifacts owned by the organization. A remote repository represents an external source such as npm or Maven Central and caches downloaded packages in Artifactory. A virtual repository combines local and remote repositories behind one endpoint, simplifying client configuration. For example, a build can request all npm dependencies from one virtual repository while Artifactory resolves internal packages locally and caches approved public packages remotely. This improves consistency, availability, governance, and migration flexibility. In your answer, define each repository type, explain request flow and caching, discuss unified client endpoints, identify security and availability benefits, and include a practical example involving internal and third-party dependencies. Question 4. How would you troubleshoot a failed Docker image pull from Artifactory? I would first capture the exact image reference and error, then verify the registry URL, repository name, tag, and user permissions. Next, I would authenticate with Docker or the JFrog CLI and test the endpoint directly, checking DNS, TLS, proxy routing, and firewall rules. I would inspect Artifactory request logs and Docker client output for authorization or manifest errors. Finally, I would compare a working user, image, and environment to isolate configuration from repository or network problems. Be sure to mention authentication, repository URL, image naming, permissions, network connectivity, TLS certificates, Docker configuration, reverse proxies, logs, token scopes, and reproducing the issue with CLI or curl. Question 5. How would you integrate Artifactory into a C/CD pipeline? I would configure the pipeline to resolve dependencies through Artifactory and publish versioned outputs there, never relying on workspace files as the source of truth. The pipeline would collect build information, including modules, dependencies, environment data, and Git commit details. Xray policies could scan the build before promotion, and only approved artifacts would move toward production. Credentials would come from the C secret store or OIDC style integration, not hard-coded variables. This creates repeatable, auditable releases. While answering, cover authenticated dependency resolution, build info collection, artifact publication, immutable versioning, promotion, security scanning, deployment gates, credentials management, and pipeline failure handling. Question 6. What is JFrog Xray, and how would you position it in a software supply chain? JFrog Xray provides continuous analysis of artifacts and their dependencies, helping teams identify vulnerabilities, license risks, and policy violations. I would connect it to repositories and builds so analysis includes transitive dependencies and release context, not just file names. Watches and policies can define severity thresholds or license rules, while exceptions handle documented business decisions. Xray does not fix vulnerabilities automatically, it provides evidence and enforcement points. Remediation may involve upgrading, rebuilding, replacing, or isolating components. In your answer, explain component indexing, vulnerability and license analysis, watches, policies, build context, evidence-based gates, risk prioritization, and the difference between detection and remediation. Question 7. A customer says Xray reports too many vulnerabilities and blocks releases. How would you respond? I would avoid simply disabling the policy. First, I would classify findings by severity, exploitability, exposure, and whether the vulnerable component is actually present at runtime. Then I would separate direct from transitive dependencies and identify upgrade or exclusion options. Policies can block critical production risks while warning on lower risk findings, with time-bound exceptions requiring ownership and justification. I would present a remediation backlog and measurable targets, preserving security controls while preventing noisy alerts from eroding developer trust. Make sure to cover triage, exploitability, severity, affected versions, direct versus transitive dependencies, policy tuning, exceptions, upgrade planning, compensating controls, and communicating risk without weakening governance. Question 8. How would you make artifact builds reproducible across developers and C agents? Reproducibility starts with resolving every dependency through a controlled Artifactory endpoint and pinning exact versions or lock file entries. I would avoid mutable tags, capture checksums, use consistent build images, and ensure developers and C agents share equivalent toolchains. Build info records the inputs and environment needed to investigate differences later. Remote repositories should cache approved versions instead of allowing uncontrolled internet access. Reproducibility is a process property, so repository policy and developer workflow must reinforce it. Focus on immutable versions, repository pinning, dependency locking, checksums, isolated build environments, build info, controlled remote repositories, containerized tooling, and avoiding mutable tags or untracked local dependencies. Question 9. How would you migrate a customer from Nexus or another registry to JFrog Artifactory? I would begin with an inventory of formats, repositories, consumers, retention rules, permissions, and critical release paths. Then I would map source repositories to Artifactory local, remote, and virtual structures and test representative builds. I would transfer required artifacts and metadata, validate checksums and permissions, and update clients through controlled configuration changes. Running both systems briefly reduces risk, while monitoring download failures and pipeline behavior. Finally, I would freeze writes, perform a final sync, switch traffic, and retain rollback options. Be sure to mention discovery, package inventory, repository mapping, metadata preservation, permissions, client endpoint changes, bulk transfer, validation, parallel operation, rollback, and communicating migration impact. Question 10. How would you use JFrog CLI and REST APIs in a customer solution? I use the JFrog CLI for repeatable developer and pipeline operations such as configuration, file transfer, build info publication, and promotion. I use REST APIs when a platform needs custom orchestration, reporting, or integration with ticketing and deployment systems. Authentication should use scoped tokens or C-managed credentials, with secrets excluded from logs. Scripts should be idempotent, validate responses, retry safely, and handle pagination. I prefer supported CLI commands for common workflows and APIs when product-specific automation genuinely requires them. In your answer, discuss automation boundaries, authentication, configuration management, uploads and downloads, build info, AQL, ID impotency, error handling, rate limits, and choosing CLI versus API appropriately. Question 11. How would you investigate slow artifact downloads from Artifactory? I would establish a baseline using the same artifact, client, and region, then measure DNS, connection setup, transfer time, and throughput. I would determine whether the request is served locally or fetched through a remote repository, because cache misses can explain first download latency. Next, I would inspect proxy behavior, storage performance, concurrency, and server metrics. Regional replication or edge caching may help globally distributed teams, but I would confirm the bottleneck first rather than adding infrastructure prematurely. While answering, cover client location, network latency, bandwidth, repository caching, storage performance, replication, reverse proxies, concurrent load, large file behavior, logs, metrics, and establishing a baseline before changing architecture. Question 12. What artifact security controls would you recommend for a regulated enterprise? I would combine least privilege project permissions with enterprise identity integration, scoped access tokens, TLS, and auditable administrative activity. Production repositories should restrict deletion and overwriting, while Xray policies govern vulnerabilities and licenses before promotion. I would define retention and backup policies, test restoration, and separate artifact publication from production deployment approvals. Audit evidence should connect users, builds, dependencies, approvals, and releases. Controls must be practical enough that teams follow them consistently, not merely satisfy a checklist. Mention least privilege, identity integration, access tokens, TLS, audit logs, immutable releases, Xray policies, retention, encryption, separation of duties, backup testing, and evidence needed for compliance reviews. Question 13. How would you design a high-availability Artifactory deployment? I would begin with required availability, recovery time, recovery point, traffic volume, and geographic constraints. For high availability, I would use multiple Artifactory nodes behind a load balancer, resilient storage and database components, and separate failure domains. Backups must cover configuration, metadata, and binaries, with restoration tests proving they work. For regional disaster recovery, replication and documented failover procedures are essential. I would monitor node health, storage latency, queues, errors, and capacity, because redundancy without observability creates false confidence. Focus on redundancy, shared or replicated storage, load balancing, database considerations, topology, backups, disaster recovery, replication strategy, failure domains, monitoring, and distinguishing availability from recovery objectives. Question 14. How would you explain artifact promotion and release governance to a development team? Promotion means moving the exact tested artifact toward release, not rebuilding it for each environment. A pipeline can publish to a development repository, run tests and Xray checks, then promote the same build after approval to staging and production. Build info records provenance, dependencies, and commit details, making rollback precise. I would automate routine gates and reserve human approval for risk-based decisions. This approach preserves developer speed while ensuring production receives what was actually tested. In your answer, describe immutable builds, environment repositories or properties, approval gates, build provenance, promotion versus rebuilding, rollback, automation, and balancing developer speed with production confidence. Question 15. A customer wants to store every build forever. How would you advise them? I would first clarify why indefinite retention is required: compliance, rollback, debugging, or regulatory evidence. Usually, released artifacts and build metadata deserve longer retention, while disposable snapshots can follow shorter, ownership-based policies. I would use immutable release repositories, cleanup rules for unreferenced development artifacts, and backups aligned with recovery requirements. Before deletion, I would validate dependency relationships and legal holds. Retention should preserve the ability to reproduce and audit releases without turning storage into an uncontrolled archive. Be sure to discuss storage cost, legal and audit requirements, reproducibility, release retention, cleanup policies, snapshots, dependency usage, immutability, restoration needs, and distinguishing valuable provenance from unnecessary binaries. Question 16. How would you secure and manage container images through JFrog? I would establish approved base images and require teams to build through controlled Docker repositories. Images should be tagged with immutable version identifiers, scanned for vulnerabilities and licenses, and promoted only after policy checks. Where the organization supports it, signing or attestations can strengthen provenance. Full permissions should reflect environment needs, and stale base images need scheduled rebuilds because new vulnerabilities appear after publication. I would connect image metadata to the originating source commit, pipeline, dependencies, and deployment. Cover image provenance, base image governance, Docker repository design, vulnerability scanning, signing or attestation, immutable tags, promotion, runtime context, pull permissions, and image refresh strategies. Question 17. Describe how you would run a technical discovery session with a prospective JFrog customer. I would lead with outcomes rather than product features, faster releases, fewer supply chain risks, reliable builds, or lower operational effort. I would map the current flow from source commit through build, artifact storage, security checks, promotion, and deployment. I would ask about package formats, volumes, regions, identity, compliance, and failure points, while involving developers, security, and operations. Then I would summarize assumptions, propose a focused proof of value, and define measurable success criteria before recommending architecture. In your answer, cover business outcomes, current tools, developer workflows, package formats, scale, security requirements, pain points, stakeholders, success criteria, and translating findings into a validated solution design. Question 18. How would you handle a proof of concept where the customer's success criteria are unclear? I would pause implementation long enough to agree on the problem and measurable outcomes. For example, success might mean reducing dependency resolution failures, cutting release time, or blocking critical vulnerabilities before deployment. I would document the current baseline, choose representative repositories and pipelines, define acceptance tests, and assign responsibilities on both sides. The proof of concept should be small but realistic, with scheduled checkpoints. At the end, evidence should support a go, revise, or stop decision. Focus on clarifying business and technical goals, baseline metrics, scope, stakeholders, acceptance tests, timeline, risks, responsibilities, and converting vague enthusiasm into measurable proof of value outcomes. Question 19. Tell me about a time you had to explain a complex technical trade-off to a non-technical stakeholder. In one project, a stakeholder wanted every dependency blocked unless completely risk-free, which would have stopped releases. I explained the issue using a simple risk matrix: severity, exploitability, exposure, and available mitigations. We compared strict blocking with risk-based policies and discussed delivery impact. I recommended blocking critical exploitable issues while warning on lower risk findings and tracking exceptions with owners and deadlines. The stakeholder understood the trade-off because the discussion connected technical controls to release reliability and business risk. Be sure to demonstrate audience adaptation, business framing, clear options, quantified trade-offs, active listening, visual explanation, recommendation rationale, stakeholder alignment, and confirming understanding without oversimplifying risk. Question 20. Why do you want to join JFrog as a solutions engineer? JFrog appeals to me because artifacts sit at the intersection of development velocity, security, and reliable production delivery. As a solutions engineer, I could combine technical depth with customer discovery, understanding a team's pipeline, demonstrating Artifactory and Xray in context, and helping turn policy into practical workflows. I enjoy explaining complex systems clearly and validating solutions with measurable outcomes. JFrog's broad ecosystem also creates opportunities to solve real integration problems, not just present isolated product features. In your answer, connect JFrog's software supply chain mission to customer impact, explain your technical and consultative strengths, reference relevant products or workflows, and show curiosity, ownership, and measurable value creation. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.